welcome you to Lecture 15, Unit 3. This is Counting Rules. My name is Jorge, and this is for Statistics 2023. So when we do probability, there are obviously rules and rules and rules, right? But they make finding the probabilities of what we're looking for easier to find. So we have several objectives. So the first thing is we're going to find a total number of outcomes in a sequence of events, and this is going to be using the fundamental counting rule. Then we're going to find a number of ways that R objects can be selected from N objects using the permutation rule. And then we're going to find a number of ways that R objects can be selected from N objects without regard to order. And then we're going to use the combination rule. So many problems in probability and statistics require us to know the possible outcomes of situations. So to determine this number, three rules can be used: the fundamental counting rule, the permutation rule, and the combination rule. And that's what we're going to do in that order. So the first thing is the fundamental counting rule. So in the sequence of n events in which the first one has k₁ possibilities, and the second event has k2, and the third has k3, and so forth, then the total number of possibilities of the sequence will be the product of k₁ times k2 times k3 all the way to kn. So in this case, n means to multiply. So here's an example. A security supervisor of a large corporation wishes to issue each employee a parking permit with a 4-digit number. How many permits can be issued? So you have four digits. So how many possibilities for each digit? So since there are no restrictions, anything from 0 to 9 is possible. So there are 10 for each one. So 10 for the first one, 10 for the second, 10 for the third, 10 for the fourth, gives us 10,000 possibilities, or 10,000 permits. Here's the next example. Professor gives a 5-question multiple choice exam. There are four possible responses to each question. So how many different answer keys can be made? Now, only one of these keys have the correct answers, right? So we have 4 possible answers for the first, 4 for the second, 4 for the third, all the way to the fifth. So there's 1,024 possibilities. The next thing, which is not quite permutation, but we use it to find permutations and combinations, is factorial. So for any counting number n factorial, and that's what the exclamation mark is read, is equal to n times n minus 1 times n minus 2 all the way down to 1. And 0 factorial is actually equal to 1. So for example, 5 factorial then would be 5 times 4 times 3 times 2 times 1, which is 120. So this leads us to permutation. So a permutation is an arrangement of objects of n objects in a specific order. So it is written as n choose npr, so n permutation r. And the formula then is n factorial divided by n minus r factorial. So here's an example. A school music director can select 2 musical plays to present next year. One will be presented in the fall and one will be presented in the spring. If she has 7 to pick from, how many different possibilities are there? So the formula we're going to use is this one. And in this case, 7 is the n, r is the 2. So 7 factorial divided by 7 minus 2 factorial gives us 42. So there's 42 possibilities that you can choose from. The next example of a permutation. A television news director wishes to use 3 news stories on the evening show. One story will be a lead story, one will be the second story, and then the last one will be the closing story. If the director has a total of 9 stories to choose from, how many possible ways can the program be set up? So again, here's the formula. And then here's what we're going to do. So it's going to be 9 factorial divided by n minus 3 factorial. So it's 504 possibilities. So let's talk about combinations. Suppose a dress designer wishes to select 2 different colors of material to design a new dress. And he has on hand 4 different colors. How many different possibilities can be there in this situation? So this type of problem differs from the previous ones in that the order of the selection is not important. The selection of red and yellow is the same as the selection of yellow and red. And this is what we call the combination. So we don't double count it. So RY would be the same as YR. So the selection of distinct objects without regard to order is what we call a combination. Now, the number of combinations of R objects selected from N objects is denoted by N choose R and is given by this following formula. So the difference between combinations and permutations is that in permutations, RY is different than YR. And in combinations, they're considered the same thing. So how many combinations of 4 objects are taken 2 at a time? So here we have 4 objects taken 2 at a time. 4 factorial divided by 4 minus 2 factorial times 2 factorial gives us 6 different possibilities. So in order to survey the opinions of customers at local malls, a researcher decides to select 5 malls from a total of 12 malls in a specific geographic area. How many different ways can the selection be made? Again, combinations. So 12 factorial divided by 12 minus 5 factorial times 5 factorial gives us 792 possibilities. And that's the end of Lecture 15, Unit 3. Thank you.